Cool. So hi again, everyone. I'm hoping that most of you are already were there on my previous session, so I probably don't need to reintroduce myself. This is a slightly different session, again, focusing on error handling and also a bit more on logging this time, but on a completely different tool, which is Power Automate Desktop. Even though it has Power Automate in its name, it's a vastly different tool, so that's why it deserves its own session. Right. So, yeah, okay, that's my intro slide, but I won't go through this again because I assume that you've already heard this previously. I'm your Power Automate guy. There we go. So, the agenda again is very similar. I'll share a few slides on the basics of how to handle errors and log them in Power Automate desktop flows. And then I'll switch to a demo where I'll actually show you some of those flows and some of those functionality. And then we can have some Q&A at the end. Right, so again, the reason I talk about this is the same as it was with cloud flows. Handling errors is important, obviously, because we don't want our flows to break when they run in enterprise environments. And once again, Power Automate Desktop, the same way as cloud flows, it just doesn't come with any sort of a framework or anything, any templates or anything like that out of the box. So we need to build it ourselves. And that's why I keep talking about this topic on the different sessions. And like with cloud flows, even though it's actually very different, but there are, again, three types or three approaches to handling errors in desktop flows as well. And that also at a high level, they're actually similar to those of cloud flows. So first of all, we can simply do no error handling, which again will mean that our flows will fail on the first error, which is again not recommended. Don't do that. A slightly better approach again is action level error handling, which, yeah, again, even is called the same way as it is in cloud flows, where we actually set these special rules on every single action that could potentially fail. But it's not really recommended either. And I'll talk about that in a minute on why that's not really recommended. But the actually recommended way of handling errors in Power Automate Desktop is using the so-called error blocks. They're similar to scopes, but actually work slightly differently. And they essentially allow us to set rules on groups of actions or entire subflows or even the entire flow if we wanted to. Right. So action level error handling, even though I said it's not recommended, it does actually work in some scenarios. It's worth a mention. So what it looks like in Power Automate Desktop is that we on every, or at least most actions, actually not every action, but on most actions, we get the on error options available. And when we click on that, we can actually set plenty of different rules and options for error handling. And it's very powerful. There is lots of functionality in there, and it is actually set on the action that we want to handle, unlike it with Cloudflow. So that's something I actually prefer. So we have the retry policies. This is a sample screenshot of the execute SQL statement action and its settings for error handling. We can have the retry policies. We can set the action to retry a few times with different intervals before it actually starts assuming there was an actual error. And then even if it doesn't work, when it doesn't work after the retries, we can set plenty of different rules. We can set, run some subflows, we can set variables, and we could essentially add as many as we want of these. Then we can decide on whether we still want to throw an error afterwards or continue. And if we choose to continue, we get to choose some options like going to a label or repeating the same action or whatever. And we even have the options to actually set different rules for different types of exceptions based on the context of the action. So for example, the execute SQL statement action could potentially have 3 different types of exceptions. That's what Power Automate Desktop actually expects. And we could set these rules differently for each type of exception if we wanted to. So not that I recommend doing it, but if it makes sense for your business case, this is an actually very powerful feature. However, there are obviously some drawbacks to this approach. And first of all, it's very time consuming to both build and maintain this. So imagine an actual real enterprise scenario with a large flow, plenty of subflows, plenty of actions. Building that into all of those actions would take lots of time, and then maintaining it, if you want to change something in your handling, then yeah, that's also quite painful. But that's not even the biggest issue. The greatest issue with this approach is the fact that it doesn't actually handle all errors. And that's first of all because it doesn't apply to all actions, because on some actions we simply don't even get the on error button, don't even get these options. And that's because Power Automate Desktop kind of silently assumes that action cannot fail. And it's actions like, for example, set variable, which can actually fail if we put in some, funky syntax in there. But yeah, it assumes that this action cannot fail, and we don't even get any options to actually handle errors on it. And then it doesn't actually handle the so-called unexpected logic errors. So these are the sorts of errors that Power Automate Desktop simply doesn't expect. So it's an error like the index out of range exception, right? When we target a list, but we set an index that is actually out of bounds of the actual length of the list, or the object doesn't contain property named something exception, or the data table doesn't contain column named something exception. These sorts of things, usually related to referencing values inside more complex variables, these are considered to be unexpected logic errors. And if it happens, even, it can happen even on an action like this, on a execute SQL statement action, if we put it into the statement field. But even if we set the action to handle all errors, these unexpected logic errors will not be picked up, and the action will still fail. And that's a huge issue, obviously, because this essentially means that we cannot trust this approach to handle our flows properly. That's why it's not recommended. I would usually recommend using these only in some very specific scenarios where you maybe want to handle a certain action differently than the rest of your flow. So we frequently use that, for example, with the wait for something actions, where we're waiting for an element to appear or disappear on the screen, or some text or whatever. And when that happens, we usually don't want our wait to last infinitely, so we make it fail on a timeout. But then, when that happens, the error message on every single wait for something action is always the same. It just says timeout has expired, which is pretty useless. So we usually make it, we set the custom handling to just continue the flow run regardless of the error, and then we put in a condition afterwards to check whether or not the item that we were waiting for has actually appeared or disappeared from the screen. So that's what we usually do. But I would assume there could be some other business cases where it makes sense. That's because action level error handling actually takes priority over the error blocks, meaning that if there is an exception on an action and that action has action level error handling set on it, this will take priority, and then the block will only kick in if the action is still set to throw an error. So it does make sense in some cases, but obviously not recommended to use on all actions. And the actually recommended approach is, as mentioned, using the error blocks. And the reason why it's recommended is because, well, first of all, it's, again, very powerful. Similarly, we have all of those rules and so on. We can set whatever we want to do when an exception happens. It's much easier to set up and maintain because we only need to set this once for a group of actions, for an entire subflow, or if we're feeling extremely lazy, we could just have this, a single block in main, because it actually handles subflows that are called from within the block. So technically, you know, if we call our subflows from within the block, and we don't even need to handle, you know, put in the blocks in the actual subflows, we could just have one, but that would still lead to the flow actually stopping as soon as there is an error. So that's not really recommended, but it's possible if you wanted to. And the most important thing about this is obviously that it can actually handle all exceptions. That is, if we enable this toggle over here. I have no idea why Microsoft thought that this needs to be disabled by default, but it is disabled by default when we add an unblock error action to our flow. But if we enable it, the capture unexpected logic errors toggle, it will actually capture those unexpected logic errors. And that's essentially the only way to capture them. And that's why this approach is the recommended approach to actually handle all errors in your flow. Now, obviously, there are a couple of drawbacks with this as well. There's a bit less options here. We don't have the retry policy functionality in here because it applies to several actions and not a single action. And, you know, because of the same reason, we don't get the different types of exceptions or different types of rules based on the type of exception, because we don't have the context of the action that could fail when the block actually covers multiple actions. So there's less options available, and the same rules will obviously apply to all actions within the block. But there are ways to work around that, and I'll show you that in the demo. Right, now, it's cool to handle errors, obviously, but if we simply handle them, again, we don't really want our flow to just continue. We also need to log them somehow, because otherwise it would be quite difficult to figure out what happened, what caused the issue, and then, you know, fix it somehow. Power Automate Desktop does contain an action called log message. That's the only functionality related to logging in Power Automate, but in my opinion, it's pretty much useless. All it does is it logs the message into the flow run action details in the cloud portal. Now, well, first of all, what this means is that it's a premium feature because we need to have access to the cloud portal, but you know that isn't probably the major issue. The major issue is the actual interface of the flow run action details. If you've ever seen it or used it, you know it's quite a pain to actually use it. It's not great. It's quite difficult to navigate. It's got lots of logs in there because every single action that runs in your flow will actually be logged in there. It's quite difficult to filter and find anything you're actually looking for in there. There's no export functionality, and it is limited to only log up to 10,000 messages per flow run, meaning that if you've got a large flow or a loop that processes lots of items, then you're at the risk of actually losing some data on your logs. And you know that's why my opinion is that, you know, while using this is, you know, kind of better than having no logging at all, it's still, you know, pretty much any custom logging alternative would work better than using this action. Right. As for better custom alternatives, I've seen a few over the years, people using different ways in logging. The most popular I've seen are things like logging to a database, for example, which works well for technical people, not so much for non-technical people. And we might have to resort to building interfaces on top of those databases afterwards. Logging to SharePoint lists is also an option as well. And it's kind of more user-friendly to users because it's essentially an interface on top of a database. So that's slightly better. Or simply logging to files like CSV files or plain text files, which are, you know, quite easy to implement, usually quite user-friendly as well. Now, I personally prefer logging to simple plain text file. And there are a couple of reasons why. First of all, it's very easy and simple to set up in Power Automate Desktop, mainly because there's a wondrous action called write text to file, which will create a file if it doesn't exist, or append a line to the file if it does exist. So it's very simple to set up with just a single action to actually create your logs. And it's also much less likely to fail due to application errors than, for instance, writing to a database or a SharePoint list or something like that, because it's just creating a simple file on the local machine. So network doesn't really influence it, and also the actual applications as well. I also prefer it over CSV files because it doesn't require headers. It's usually, supports better syntax and, more customizable. The one limitation of using this, and, regardless of whether we do just a plain text file or a CSV file or whatever, over actual logging into a database, a Dataverse table or a SharePoint list or something, is the fact that, well, these files are obviously local. What this means is that, that they're usually only accessible on the machine where it runs, unless we actually push them to a network location or some sort of a monitoring software. Right, so that's that for the basics, and it's time for me to, well, not really stop talking, but at least stop sharing the slides and switch to a demo. Right, so again, I've got a demo. I've already built a couple of flows, because if I were building them now, this wouldn't really be a 45-minute session. It would be more of a full-day workshop. But I'll show you what they are and the important parts of it. Now, again, I like adding some context. I don't like building flows that do nothing. So for this particular case, I thought I would like to buy something nice to my wife because I love her. And nothing says better than I love you than a bouquet of flowers. And it's even better if it's Lego flowers because we both actually love Legos. However, I would usually look for them in the botanical collection of Lego, which we both love. But unfortunately, I actually have already purchased most of these already to her. The one that I'm actually missing is the tiny plants, this one. Yeah, arguably, this doesn't really say I love you as much as, for instance, the bouquet of roses, but I have already given this to her for Valentine's Day. So yeah, I'll ignore that one. So yeah, I went with this one. And I thought, yeah, okay, well, it's kind of pricey, but that wouldn't really be an issue. But then I figured that, since I need a flow for a demo, why not build a flow that actually scrapes this and gets me a notification when it's on sale so that I can grab it. And, I know Lego.com does some sales from now and then. We get an extra item over here next to the normal price, which just has a discount price, usually up to 30 or 40%. And, I could just grab that. But in order to actually grab that, I first needed to find an actual other product that does have the discount. So I can actually capture this and then build a flow that scrapes the web page. Right, so I went to the sales page over here, and most of these aren't really interesting to me. So I just went with a random one like this one for Marvel fans. I don't really want this one, but at least it has this element that I can capture. Right, and so I can build some flows that could potentially, scrape this and check when it's on sale. However, obviously, when I started browsing through Lego.com, I found plenty of other sets that I would want for myself as well. So I built a list. And in this case, for the sake of simplicity, I just put them all into Excel. So here's a list of 8 different sets. One of these actually includes the tiny plants that I want to buy for my wife. The last one is actually the Guardian's ship for the discounted set, so that I can actually have something on discount for the purpose of the demo, and the others are just some nice other sets that I would want for myself. And then I built a couple of flows. I built 2 because I like the idea, the single responsibility principle of software programming, where I like my flows doing one thing and one only. So what I have is a work item generator flow that reads the list from Excel and creates work items for me in a database. And then I have the processor flow that actually processes those work items. Now I use my own SQLite database or a SQL server. I could do whatever, but it's our own framework that we have delivered with my team. And I don't really like the queue functionality in Power Automate as it is right now. So that's why I'm just gonna, for the sake of simplicity, work with this as well. Just quickly show that my database currently has no work items that are unprocessed, and I'll run the generator flow. I'll just run it to generate those work items. I won't really demo it to you because that's outside of scope for the demo. But I will show you the work item processor flow. Right, so this is what it is. And yeah, as you may notice, it actually has 44 subflows. That's quite an overkill for a flow that's pretty simple. That's because I actually built it based on the actual standard framework that we have created and polished over the years with my team. And what the reason why we have that and why we use it is, well, first of all, simplifies and shortens development time for us significantly. I can build a flow like this within an hour because I copy most of the framework over when I start a new project, and then I only need to add a few custom subflows and actions based on some templates. So it really makes it very, well, makes me very productive. And on top of that, what it also means is that if I need to, if I build a flow like this and put it into production, and then someone else in my team actually needs to provide some support and maintenance to it, they actually can easily navigate through it, even without reading any documentation, because it all follows the same standard structure. So it's easier for us to also provide support and maintenance, even when the person who actually built the flow is not available. Right. So it has those 44 subflows, but I'll only show you 5 that are actually relevant for the topic. The rest are just things that handle the database interactions and all sorts of stuff like that. Right. And now what I would like to start with is the essence of handling errors. So as mentioned, the recommended way is using on-block error. Right. So we have that in almost every single of those 44 subflows, with only a few exceptions. We have an on-block error that is set up exactly the same. In all cases, it's simply set to set a trace level log message and call a log to file subflow that handles the logging. And then it continues the flow run going to the end of the block, effectively meaning skipping all of the further actions inside this subflow, because the end of the block is at the end of the subflow. And it's obviously set to capture unexpected logic errors because we want to handle all errors. Right, so when an error actually kicks in, log to file actually starts, and that's the one, that's pretty much the most important subflow in our framework when it comes to actual logging. So what it does, it essentially creates those logs in plain text files, but formats it in JSON, so it has some text processing in there, and then it has some very important steps in here. First of all, it will check the level of the message. So that's what we set previously. Trace is a level that indicates there is a system exception. We only set that in the on error blocks, meaning that it can only be set to trace when there is an actual exception to handle. So when that happens, we want to get the details of the error. And we get that by using the get last error action. Now, if you've ever run a desktop flow via the designer in debug mode, and there was an error, you notice there's this error pane popping up over at the bottom of the screen showing all of the details of the error. Those are pretty useful when we actually debug flows, but they don't really come up like that during runtime in production. We get a notification that's pretty much useless. It disappears pretty soon, and if it's actually running on a remote machine on an unattended mode, we don't even see it. So it's not really useful. And that's where get last error comes in, because it actually returns all of those details that we would see if we ran the debugger. So it returns things like the name of the subflow, where the action that failed actually resides, the name of the action itself, the sequential number of the action within the subflow, and also all of the other details. And it returns all of that in an actual object that we can parse. So it's very useful. And that is really the essence of actually capturing a custom error message while using error blocks, which essentially applies the same rules to all actions. We still get the details, and we know which action failed and why, without setting custom messages on every single action. Right, now with that in mind, we can continue. The next important thing over here is that we also use the same subflow for logging everything else as well. So we sometimes simply call it by using the run subflow action, and we log other types of messages. We log business exceptions that we define manually. We log info messages, debug messages, just some various types of messages. And when that happens, we also want to get some details, like, for instance, the name of the subflow from which the message originates. Now, we get that using the get last error when there is a system exception, but when there is no system exception, we don't really get it. So what we used to do is we used to define it on every single message when we logged it, but we found that to be tedious, so we did a slight modification to the approach, and we use a list. And we call it function names because we're old school like that. We built it way back in bin automation times when subflows were called functions, and we didn't care enough to rename it afterwards. But this is essentially a list of subflow names. And what we do is in the beginning of every subflow, we add the name of the subflow to the list. So we actually need to manually define it once per subflow. Then at the end of the subflow, we remove it from the list as the last item of the list, meaning that we don't really target a specific item, we just get the last item. If we call another child subflow from here, it does the same thing. It adds its own name, meaning that this name will be the last item, and at the end, it removes it again. So again, returning back to here, the last item is still the name of this particular subflow. And that's why it works with any level of subflows, any depth of nested subflows. And then in log to file, we just get it again as the last item of the list. So whenever we call log to file, we pick it up like that, and we no longer need to define it on every single message. So we still need to define it once per subflow, but it is significantly less time consuming than doing it on every single message. Right, and then the final thing in the subflow that I want to mention is a thing called the logger object. And we've got a config, an external configuration file that helps us configure our flow runtime without actually modifying the flow. So we pass in some variable values from the file. It could be on a database, on a Dataverse table, or whatever. It could just be a simple file somewhere. And within that file, we have an object called logger object that has a couple of parameters. One of them is log levels. So what this does is this specific condition checks whether the level of the current message that we're trying to log here is included in this object. And if it is, then it means it needs to be logged. So we log it to a file with all of the details that we want in there as a JSON blob. If it's not, then we skip it and we don't log it. And that's a simple way to manage what we actually log without modifying the flow itself. For example, we always log this sort of debug level messages whenever we start the hypercare. So after actually deploying our solutions to production, we have hypercare for a certain period of time. And then, you know, when it's done, when it's over, we disable these debug messages so we don't clog the logs. And when that happens, we don't really want to redeploy the solution just so that we can disable the debug logs. So we just modify that in config, and that's it. And that's enough to handle this change. And then another object or property in this object is called error log levels, which does a similar thing, but in this case, we're actually also sending some messages to an error recipient at the end of the flow. So we have a send error messages subflow that will send any error messages, if there were any, to a process owner. It's usually a business user, so we need less details. We usually don't include all of the logs, only the relevant messages, and with less details, only the actual relevant details. So in this case, we're checking whether the error log levels list actually contains the current level. And if it does, then we add this to a list, and that's what will be sent to the user at the end. If it doesn't, it means that it's a log that shouldn't be sent to the user, and we still log it, but we don't send it. Again, can be configured without modifying the flow. Right. So as mentioned, we use this subflow to log different kinds of messages, and there I can demonstrate some of them in a subflow like this. This is a custom subflow actually that converts the price to a numeric value after scraping it from the web page. So we log, for example, the an info level message at the start of the subflow and at the end of the subflow, simply because that helps us trace the actual runtime better when we're actually reading the logs if we are. And we sometimes log some non-sensitive variable values. So for example, in this case, we actually log the price after converting it to a number so that we can see it and we can figure out what value it was at during runtime. And maybe that helps us figure out the potential issues. And we sometimes log some business exceptions that are not really system exceptions, but are still errors. So in this particular case, if we actually pass in an empty price to this subflow, that's an error because we can't really convert it to a number. So we throw an error, but that's not a system error. That's actually a business exception. And what we do then is we make this subflow fail, and then we make the parent handle the actual error. And that's the idea. That's also why we use blocks at subflow level, is because we then want to have custom error handling in the parent level. So we can actually implement some sort of rules when a child flow actually fails. So in this particular case, I have this execute webflow subflow that's slightly larger. What it does is it actually handles all of the web user interface interaction for this particular flow. So it actually opens the browser, it navigates to lego.com, finds the product, scrapes the prices, converts them, and then checks if there is a discount. And what I've got in it, I've got plenty of child subflow calls, and I've got them all in a loop. Now this loop isn't really meant for processing work items because I've got that one in a further parent over there in a subflow called process work items. This one is actually intended to implement a retry functionality. So what it does is it actually loops from 0 to a maximum allowed number of retries for a specific type of system. And that's, again, configurable in the external config. And this loop will call all of those functions. And if all of them actually succeed, then there's an exit loop action at the end, which sounds a bit counterintuitive, but the idea behind it is that if everything succeeds, we don't really need to retry. So we exit and we continue. But if any of these actually fail, then we implement some sort of functionality. And every single time we simply check whether or not there is an error message. If there is one, that means the child subflow failed, and then we can do whatever we want. So in some cases, we might want to escalate that further to the further parent, so we do go to failed. In some cases, we might want to retry or just continue without doing anything and so on. So in most cases, within this subflow, we use next loop. What this means is that further actions within the loop will be skipped, and we'll go back to the next iteration. If we haven't exceeded the retry count, then it will retry. But for example, there is one custom subflow in here that's called get sale price that has a different rule, and this is because of the context of the business logic, right? So as mentioned, I use this flow to get myself deals on the products I want. So in most cases, whenever it actually runs, it is expected to not find the sales price, because as soon as it finds one, it will notify me, and then I'll, presumably purchase the product and will remove it from the list because I no longer need it. And as such, this subflow is actually expected to fail most of the time, but I don't want the flow to retry it or to actually, stop because of it failing. What I want is for it to just, log a warn level message, which won't be sent to me, and then, set the sale price to actually to be equal to normal price that was actually captured previously, so that it doesn't get any discounts, and then simply continue. And that's just a custom rule that I built based on this business logic. Right, but if any of the others actually fail, then it will go to the beginning of the loop, and it will check if the error message is not empty again, so that it logs it. I didn't want to repeat the log message action after every single check, so I just put it here. And then before it actually retries, it will take a screenshot. So that's the next important thing I want to mention, is the act of taking screenshots as a means of logging stuff. That's very important, especially in flows that actually involve any sort of user interface interaction. And especially so in unattended flows where you can't really see the screen when the flow runs. So you can't really, view it running, and that makes it harder to debug it. So taking a screenshot in a flow like that makes a lot of sense, because it can then help you see what the screen looked like when the error occurred. So you can figure out, maybe see something that actually caused the issue. Now, we could potentially just put it into log to file or some other subflow and call it every time, but I don't want to take a screenshot every single time. Instead, I put it into a separate subflow, simply because I only want to call it when there is some user interface interaction involved. So I only actually call it from execute webflow. If any of its child subflows fail, then it means that it was related to a user interface interaction, and so I take a screenshot. In any of its parents or siblings, I don't do that because they're not related to user interface. And again, I have a screenshots path in config where I define whether or not I actually want to take a screenshot. If this value is actually left empty in my config, or if it leads to a folder that doesn't exist on the system, this condition will actually handle that the screenshot is not actually taken. So that's a way to manage whether or not I want to take those screenshots on error without modifying the flow. If it does get taken, I just put in a timestamp and some variables to the file name, take it and save it as a file. Right. And the final thing in this demo that I want to mention is the way we format the log file. Now, I've seen some people recommending having a single log file per flow. And I don't like that approach, because I consider that to be inefficient. What I would recommend as a bare minimum is to have a single log file, assuming that you're actually logging into files, a single log file per day per flow. Don't do one per flow run, because that's an overkill and might also make it quite difficult to navigate between the files. But having one per day is a very good way to actually make it accessible, make it easy to navigate, make it easy to find the details or the specific flow run in your logs. But it also enables actual archiving, for example, and makes it easier to navigate through lots of logs. So if your flow actually runs very frequently over a longer period of time, and you put all of your logs into a single file, the file will pretty soon become very large, hard to use, hard to navigate, and also pretty much impossible to archive in any way. If you wanted to archive old logs, you would have to manually remove them from the file. But if you log a separate file every day, then it's quite straightforward, and you can easily automate the act of archiving those logs when they become old. Now, for larger scale implementations, when you've got multiple machines running the same flow, I also recommend adding the name of the machine to the log file as well, especially if you push those logs to a network location where multiple machines might do that at the same time and might interfere with one another. If they write to the same file, it makes a lot of sense to also include a machine name. Right. Now, what a log that we actually create might look like is something like this. Now, this is arguably not very easy to read, obviously. This is just a list of JSON blobs. But if you are actually reading it and you use a more advanced text editor than just Notepad, something like Notepad++ or VS Code, like in my case, you can actually do something like this. Tell it that it's a JSON file. Just add some text highlighting. VS Code also has this cool thing called format document, which allows me to convert it to something like this, which makes it relatively easy to read if you are into reading these logs anyway. But in my case, we would actually feed it to a proper monitoring software. All right, but before we do that, I'd want to run the flow. So let's just check if the generator actually, yeah. So it generated some work items for me. And now I'll just close this and run it. And while I do, there's one last thing I want to mention is the monitoring part of those logs. So if you actually log stuff to files, you might want to either push them to at least a network location or feed them into some sort of a monitoring reporting type of software or something like that. Now, what we chose to use is the so-called ELK stack. Now, if you're not familiar, ELK stands for Elasticsearch, Logstash, and Kibana. It's essentially a group of products that are free to use if you have your own server to host it on. We went with that instead of some Microsoft service or something like that, mainly because when we serve several customers and we want all of their logs, well, at least those that agree to have their logs sent to our end, and we want them all monitored on the same environment without having to access each tenant individually, we needed a third-party software. So we went with ELK stack. And the way it's pretty straightforward. It's easy to set up. You can find plenty of info online, so I won't go down that way because it's out of scope of the demo. But the way it essentially works is that I have a service running on my machine that's called FileBeat, and it reacts to files appearing in folders that I define in its configuration file. So I've got a YAML file over here, and it targets log files in a specific folder. So whenever there are changes to files in there, to log files, or there are new files appearing in there, all of those changes are actually parsed by FileBeat and sent to our Logstash. And then I can actually access it via a web interface called Kibana, where I built a simple dashboard to show all of those things. And obviously I'm not taken to the dashboard directly, so just give me a sec. Right, there we go. And yeah, well, I didn't really, I'm not really that great at making visuals, and I don't really care about them, but just wanted to add some random things to show you what they could potentially look like. But the idea in here is that I get all of that stuff remotely. I don't really need to access this from the same machine. You know, I'm only doing it because it would be tricky now to switch the demo to a new machine while showing it to you via Teams. But otherwise, I can access this remotely, and I can see it real time. And if I refresh this, I should probably get more errors soon. Yep, there are some coming in. So. And you know, these might be relevant to some reporting. There are plenty of different ways on which we could build them, but I don't really care about this. I only care about the errors. And what I'm getting here is, you know, the trace level messages from the get sale price subflow that I mentioned that is expected to fail. So that's all of these are actually expected to fail. And I'm getting some of them. I should at the end actually get up to 7 of them for all of the items that failed, and then one that actually succeeds doesn't actually log the error. But essentially, I'm seeing this real time pretty much, and that's great because you might wonder why I need it real time because I'm already sending myself an email message at the end. But if there are flows that run for a while, and we might want to check on them without waiting for days for them to finish, and we don't want to interrupt them by logging into the machine, then we can actually do this real time via reporting software like this. And then, if I actually saw an unexpected error appearing over here, something else than what I've got in here, then I could drill down into this, check the actual details of the error, and then decide on whether or not I actually need to look into the actual machine. We could also push the screenshots to a network location or send them via email or whatever as well. Right, so that's that. It actually finished. I think I should have received an email by now. Oh, not yet. Let's check. It's still running. Let's close the browser, but it should be done soon. But yeah, okay, so I won't really wait for an email. The email itself would just contain the one item that's actually on sale. Right, I'll just get back to these slides. And there are, again, a few quick takeaways. First of all, the essence of actually handling errors and properly logging them is using the on-block error block with the capture unexpected logic errors toggle enabled at subflow level, preferably in combination with the get last error action so that you get the actual detail. And then, you can have some sort of a config object somewhere, like even a JSON file works as well, where you control what you log. You could also control whether or not you save screenshots and where, and so on. And then I recommend creating a log file per day, per flow, and optionally per machine. Right, that's it. And I actually have received the email, so this is what it would look like with a link and the discount. Right. And that's it. If there are any questions, we can handle that now. And if you want to connect with me, feel free to scan this code. I'll just check the chat. I don't see any questions. So if you have any questions, this is the time to ask them.